What if I told you one of the biggest disasters in modern history barely missed changing the entire course of civilization? Think about it for a second. What if the Tunguska explosion had happened just a few hours later? Instead of flattening a remote forest in Siberia, it could have exploded over one of Europe's biggest cities. Millions of lives might have disappeared in a matter of seconds. History itself could have taken a completely different path. What's even harder to believe is that, more than a century later, scientists still argued over what actually exploded in the sky that morning. There was no crater, no massive meteorite, almost nothing you would expect after an explosion powerful enough to knock down 80 million trees. But honestly, that's not the part that keeps me thinking. The most unsettling part is that Tunguska wasn't some impossible event that could only happen once. It was a real reminder of what space is capable of. The same kind of object could enter Earth's atmosphere again. It doesn't care about borders, countries, or cities. It only takes the wrong place at the wrong moment. And once you realize how close the world came to a completely different history in 1908, you start looking up at the sky a little differently. It all started on the morning of the 30th of June, 1908. Deep over the forests of Siberia, something exploded high above the ground. There was no warning, no countdown, just a flash so bright that people said it looked like the sky had ripped open. The blast was almost impossible to imagine. Scientists now estimate it released energy equal to thousands of Hiroshima bombs. In just a few seconds, around 80 million trees were knocked down across more than 2,000 square kilometers. An entire forest was flattened, as if it had been hit by an invisible force. But what happened next made the event even stranger. The shockwave didn't stop in Siberia. It traveled around the planet. Instruments thousands of miles away picked it up as it circled the Earth. Seismic stations recorded it. Air pressure monitors detected it again, hours later. One explosion, in one remote place, was powerful enough to leave its mark across the world. Then came the nights that nobody could explain. For several evenings after the blast, the skies over Europe stayed unusually bright. In cities like London and Stockholm, people could walk outside late at night without streetlights. Some even read newspapers outdoors after midnight. Photographers developed pictures in the open air. Astronomers watched the strange glow stretch across the horizon and struggled to explain what they were seeing. If you only heard that part of the story, you'd probably expect investigators to find a massive crater or the remains of a giant meteorite, but they found neither. There was no crater carved into the ground. No giant rock waiting to be discovered. No obvious pieces of the object that caused one of the most powerful explosions in modern history. It was as if whatever came through the atmosphere had simply vanished. That was the moment the real mystery began. How could something powerful enough to flatten millions of trees leave almost nothing behind? What exploded over Siberia that morning? Was it really a meteor, a comet, or something scientists still didn't fully understand? More than 100 years have passed, and Tunguska is still one of the most fascinating mysteries in modern science. Not because we know exactly what happened, but because the evidence raised even bigger questions than the explosion itself. The first clues didn't come from scientists. They came from ordinary people who happened to be there. One of them was Sergei Semenov. On the morning of the 30th of June, 1908, he was sitting outside a trading post about 40 miles from where the explosion would happen. It seemed like a normal morning. Then, everything changed in an instant. Semenov later said it looked like the sky had split open. He wasn't talking about a simple flash of light. He described a huge object crossing the sky, brighter than the sun. Then came something even stranger. Before he heard any explosion, he felt an intense wave of heat. It was so hot that he thought his shirt had caught fire. He instinctively threw his arm over his face, trying to protect himself. Only after that did the blast arrive. The shockwave hit with unbelievable force. It lifted him off the porch and threw him several feet through the air. He lost consciousness for a short time. When he finally came to, the windows around him had already shattered. Today we know why that happened. The pressure wave moved faster than the sound itself, so the force reached him before the noise ever did. But Semenov wasn't the only witness. The Evenkey people, who had lived in that region for generations, believed they had seen the anger of the fire god. To them, this wasn't just a natural event, it was something sacred and terrifying. Many families refused to go anywhere near the blast area for years. Some wouldn't even say its name out loud. The destruction wasn't limited to the forest. Entire herds of reindeer and other animals were found dead. Some had been killed by the shockwave. Others showed signs of severe burns. The people who depended on those animals for survival suddenly lost almost everything. Hundreds of miles away, the event was still impossible to ignore. A train engineer on the Trans-Siberian Railway felt such violent shaking that he slammed on the brakes, convinced the train had jumped the tracks. He climbed out to inspect the rails, expecting to find major damage. Instead, everything looked perfectly normal. Only later did he realize the ground itself had been shaken by the blast. What's remarkable is how similar all these stories were. Different people, different languages, different cultures. Some lived close to the explosion, others were hundreds of miles away, yet they all described the same sequence. A blinding light, intense heat, a massive shockwave, then a sound so powerful it felt like the world itself had cracked apart. Long before scientists arrived with instruments and theories, the witnesses had already painted a remarkably consistent picture of what happened that morning. And even today, their first-hand accounts remain some of the strongest pieces of evidence we have about the Tunguska event. You'd think an explosion this massive would bring scientists running almost immediately. It didn't. Incredibly, nearly 20 years passed before anyone actually made it to the blast site. Wars, political upheaval, and the collapse of the Russian Empire pushed scientific research to the bottom of the priority list. The biggest explosion in modern history was left sitting in the middle of the Siberian wilderness, almost untouched. Then one man decided he couldn't ignore it anymore. His name was Leonid Kulik, a Russian mineralogist who was fascinated by meteorites. After reading old newspaper reports about the mysterious explosion, he became convinced that somewhere in Siberia there had to be a giant meteorite crater waiting to be found. Getting there wasn't easy. The Tunguska region was one of the most isolated places on Earth. There were no roads leading to the site. Kulik and his team spent weeks crossing swamps, thick forests, rivers, and endless clouds of mosquitoes just to reach the area. It was exhausting, but everyone believed the discovery would be worth it. When they finally arrived, they expected to see a huge crater. Instead, they found something no one had imagined. At the center of the blast zone stood a strange patch of trees. They were burned, stripped of their branches, and completely dead. But they were still standing upright. They looked like rows of telephone poles sticking out of the ground. The team later called it the telegraph pole forest. Outside that central area, the scene became even more unbelievable. For miles in every direction, millions of trees had been knocked flat. Every trunk pointed away from the same invisible center, creating a giant fan-shaped pattern that could even be seen from the air. It was clear that an enormous force had exploded above the forest rather than striking the ground directly. But there was one problem. The crater everyone expected simply wasn't there. Kulik searched everywhere. His team drained swamps, dug into frozen ground, collected soil samples, and returned again and again over the following years. They were determined to find the meteorite that had caused all this destruction. They never did. No giant rock, no large fragments, nothing that matched the scale of the explosion. The deeper they searched, the stranger the mystery became. Everything around them proved that a tremendous blast had happened. The flattened forest was real. The eyewitness accounts matched. The damage was undeniable. Yet the one piece of evidence everyone expected, the object itself, had seemingly disappeared without a trace. Instead of solving the Tunguska mystery, Kulik's expedition only made it even more confusing. The answers he hoped to uncover turned into a whole new set of questions that scientists would spend the next several decades trying to solve. By this point, everyone agreed on one thing. Something incredibly powerful exploded over Tunguska. The real question was simple. What was it? At first, many scientists believed it had to be an iron meteorite. It sounded like the most logical answer. A huge object entered Earth's atmosphere, exploded, and flattened millions of trees. Case closed. Except it wasn't. If a giant iron meteorite caused that much destruction, where was the crater? Where were the massive chunks of metal? Kulik searched for years and found almost nothing. The evidence just didn't match the theory. Then another idea started gaining support. Maybe it wasn't an iron meteorite at all. Maybe it was a comet. That explanation solved several problems at once. A comet is mostly made of ice, dust, and frozen gases. As it races through Earth's atmosphere at incredible speed, it can break apart and explode before ever reaching the ground. That would explain why there was no crater and almost no large fragments left behind. For decades, this became the leading explanation. It made sense, and many textbooks treated it as the answer. But the story didn't end there. As computer models became more advanced, researchers realized that a stony asteroid could produce almost the exact same kind of explosion. A rocky object about 160 to 200 feet across, exploding several miles above the ground, could flatten the forest just as effectively. Now, scientists had another problem. The explosion itself couldn't tell them which theory was right. A comet and a rocky asteroid could create nearly identical shock waves. The damage on the ground looked almost the same. Without actual pieces of the object, there was no clear way to prove either idea. That's why the debate lasted for so long. It wasn't because scientists couldn't agree. It was because each theory explained part of the evidence while leaving other questions unanswered. The iron meteorite explained the energy, but not the missing crater. The comet explained the missing crater, but left questions about the chemical evidence. The stony asteroid matched many of the physics models, but for years there still wasn't enough physical proof to settle the case. For nearly a century, the Tunguska event remained one of science's biggest unsolved mysteries. Every new discovery answered one question and raised another. And that's what makes this story so fascinating. Science isn't always about finding the right answer overnight. Sometimes it's about following the evidence, admitting what you don't know, and being willing to change your mind when better evidence finally appears. For more than 100 years, the Tunguska mystery seemed impossible to solve. Scientists had searched the area. They had studied eyewitness accounts. They had built countless theories. But one thing was still missing: real physical evidence. Then, in 2013, something finally changed. Researchers examined layers of peat that had remained undisturbed since the summer of 1908. Hidden inside those layers were microscopic particles so small they couldn't be seen with the naked eye. Earlier expeditions had walked right past them without realizing what they were. Once those particles were analyzed in the lab, the picture started to become much clearer. Their chemical makeup didn't match ordinary material found on Earth. More importantly, they didn't look like the remains of an icy comet. Instead, they closely matched the composition of a stony asteroid. For the first time, scientists had physical evidence instead of just educated guesses. At about the same time, computer simulations became far more advanced. Researchers recreated the event using modern physics, testing different types of objects, different sizes, and different explosion heights. Over and over again, the results pointed to the same conclusion. A rocky asteroid, roughly 160 feet across, exploding about 4 miles above the ground, produced almost exactly the same pattern seen at Tunguska: the flattened forest, the standing trees at the center, the missing crater, the massive shock wave. Everything lined up surprisingly well. After decades of debate, the stony asteroid explanation became the strongest scientific model. But here's the interesting part. It didn't answer every question. Some chemical traces collected from tree resin and soil still don't perfectly match what scientists would expect from an ordinary rocky asteroid. They're only small differences, but they're real enough that researchers continue to study them today. That doesn't mean the main explanation is wrong. It simply means there are still pieces of the puzzle we don't fully understand. And honestly, that's how science usually works. One discovery doesn't end the story. It opens the door to better questions. Today, most researchers agree that Tunguska was most likely caused by a stony asteroid that exploded high in Earth's atmosphere. It's the best explanation we have. But even after more than a century, the event still reminds us that nature doesn't always fit neatly into the answers we expect. Some mysteries become smaller with time. Tunguska is one of the rare ones that still leaves us looking for the last few missing pieces. Here's the part that really stayed with me. The most frightening thing about Tunguska wasn't how powerful the explosion was. It was how incredibly close the world came to a completely different history. People sometimes imagine an asteroid choosing a target, like it's aiming for a city. It doesn't work that way. An asteroid doesn't care where people live. It doesn't know where countries begin or end. It follows the same path through space, no matter what's below it. The only thing that changes is Earth. Our planet never stops spinning. Every hour, the ground beneath us moves hundreds of miles through space. That means the exact place beneath an incoming asteroid depends entirely on where Earth has rotated at the moment of impact. That's what happened in 1908. The object didn't choose a remote forest in Siberia. The planet simply rotated in a way that placed that forest underneath its path at exactly the right moment. Now imagine one small change, not days, not even a full day, just 4 hours and 47 minutes. That's all it would have taken. If the timing had shifted by less than 5 hours, the same object could have exploded over St. Petersburg, which was one of Europe's largest cities at the time. Millions of people would have been directly beneath an airburst powerful enough to erase entire neighborhoods in seconds. Keep rotating the Earth, and the danger moves. Stockholm falls into the same path. With a slightly different angle, even London could have been at risk. The asteroid never changed direction. The only thing that changed was Earth's position beneath it. That's a difficult idea to wrap your head around. When people talk about close calls, they usually mean a few miles or a few seconds. This one was measured in the rotation of an entire planet. If Tunguska had happened over a major European capital instead of an empty forest, history might have looked completely different. Governments, economies, even the events leading up to World War I could have unfolded another way. We'll never know. What we do know is this. The forest wasn't lucky. The cities weren't chosen. Earth simply happened to be facing one direction instead of another when that asteroid arrived. And that's what makes this story so unsettling. The same physics still exists today. Earth is still spinning. Asteroids are still crossing our planet's orbit. Sometimes that path lines up with an empty wilderness. One day, it may not. If anyone thought Tunguska was just a one-time event, 2013 proved otherwise. On the morning of the 15th of February 2013, another object entered Earth's atmosphere. This time, it happened over Chelyabinsk, Russia, a city with more than 1 million people. Unlike Tunguska, people actually saw it happen. A bright fireball streaked across the sky. Many residents stopped to watch. Some even pulled out their phones to record it. It looked incredible, almost beautiful. Then came the shock wave. About 1.5 minutes later, the pressure wave slammed into the city. Windows exploded inward. Buildings shook violently. Flying glass filled homes, schools, and offices. In just a few moments, around 1,500 people were injured, most of them by shattered glass. It was a powerful reminder that the real danger doesn't always come with the flash. Sometimes it arrives seconds later. As serious as Chelyabinsk was, scientists were quick to point out something even more unsettling. That asteroid was much smaller than the one that exploded over Tunguska. Its explosion released only a fraction of the energy. It broke apart much higher in the atmosphere, which greatly reduced the damage on the ground. Even so, it still injured more than 1,000 people and damaged thousands of buildings across the city. Now imagine if it had been a Tunguska-sized object instead. The outcome would have been completely different. Researchers who studied both events reached the same conclusion. A Tunguska-class airburst over Chelyabinsk would likely have devastated the entire city. The destruction wouldn't have been limited to broken windows. Entire neighborhoods could have been wiped out, and the number of casualties would have been unimaginable. Chelyabinsk changed more than public awareness. It changed science. Before 2013, many experts believed Tunguska-sized events happened only once every few thousand years. But after analyzing the Chelyabinsk data, scientists realized those estimates were probably too optimistic. the numbers had to be revised. Today, the best models suggest that a Tunguska-scale airburst may happen once every few hundred years, while smaller events like Chelyabinsk are expected much more often. That doesn't mean we should live in fear. But it does mean these events are not just part of ancient history. Chelyabinsk showed us something important. The threat is still real. The difference is that now we know it's there and we're finally paying attention before the next object arrives. After learning everything about Tunguska, one question naturally comes up. Could it happen again? The honest answer is yes. The better question is whether we're more prepared than people were back in 1908. Thankfully, we are. One of the biggest changes is that we're no longer staring at the sky without knowing what's out there. Today, NASA's Planetary Defense Coordination Office tracks tens of thousands of near-Earth objects. Powerful telescopes scan the sky every night, looking for anything that could one day cross Earth's path. On top of that, there's a worldwide network of sensors that can detect objects exploding high in the atmosphere. Years ago, many of these smaller impacts would have gone completely unnoticed. Today, scientists can spot them, study them, and learn from every single event. But watching isn't enough. Eventually, someone asked an even bigger question. What if we could actually move an asteroid before it ever reached Earth? That idea stopped being science fiction in 2022. NASA launched the DART mission, sending a spacecraft to deliberately crash into a small asteroid called Dimorphos. The goal wasn't to destroy it. The goal was simply to change its orbit. And it worked. For the first time in human history, we successfully changed the path of a celestial object. It wasn't a huge shift, but it proved something incredibly important. If we detect a dangerous asteroid early enough, we may actually be able to push it off course before it becomes a threat. That's a remarkable step forward. Then there's Apophis. In 2029, this asteroid, about 1,100 feet across, will pass closer to Earth than many communications satellites. Years ago, people worried it might hit us. After years of careful observations, scientists now know it will safely miss Earth. That should be reassuring. But it also reminds us of something we can't ignore. Apophis isn't the problem. The next object we haven't discovered yet could be. That's the part we still can't control. We've become much better at finding asteroids. We've proven we can even change one object's orbit. But none of those systems can protect us from something we don't see in time. That's why planetary defense isn't really about stopping every asteroid. It's about buying time. Time to detect it. Time to calculate its path. Time to make a decision before it reaches us. When Tunguska happened, humanity had no warning at all. Today, for the first time in history, we're actually watching the sky. We haven't eliminated the danger, but we've finally stopped looking away. When I think about Tunguska, I don't see it as a story from the past. I see it as a reminder of how fragile our civilization really is. In 1908, the difference between a forgotten forest and one of Europe's largest cities wasn't a stronger defense or better technology. It was simply a few hours of Earth's rotation. Today, we've come a long way. We track thousands of near-Earth objects. We can predict many of their paths. We've even proven that it's possible to change an asteroid's orbit if we detect it early enough. That's incredible progress. But it doesn't mean we're completely safe. There are still objects we haven't found. There are still limits to what we can see and how quickly we can respond. Nature hasn't changed. Space hasn't become less dangerous. The only difference is that we're paying attention now. Maybe that's the biggest lesson Tunguska leaves behind. We can't control everything that happens in the sky, but we can choose whether we're prepared when it does. So, here's one final thought to leave you with. If another Tunguska-sized object entered Earth's atmosphere today, which city would happen to be underneath it?